Good evening, Grace. Can you hear me?
Yes, sir.
Okay.
Good evening, sir.
Good evening. So we'll continue with the yesterday's class. Did you write the sums which we did yesterday? Did you write it from the recording? Unmute yourself and talk.
Yes, I did.
Okay, good. So we'll continue. Can you just tell me till which sum you have written?
Yes, sir. So practice at 1.3, question 2, the third sum.
This one, correct?
Yes, sir.
Did we do the second part also, verify?
No, sir.
No, just the first one, right? Show the sets U, P, and P complement by Venn diagram. Okay, so we'll do the second one. Okay, before we start with the second one, we'll just revise what we did in our yesterday's class. And in our yesterday's class, we studied three main concepts. In that, the first concept was subset. This first one was subset. So when I say A is a subset of B, the meaning of this is all the elements of A are in B, or in simple words, set A is inside set B. Then second, we saw universal set. So what is a universal set? Universal set is denoted by capital U, and it is a main set which is taken into consideration, and rest all the other sets are subsets of your universal set. Then we saw complement. Complement of the set. So if you have a universal set U and a complement are all those elements in U which are not in A. Okay, that will be the complement of A. So this was the things that we studied yesterday, the concepts, and we did first few sums we did. And now we'll continue with the second part of this. And the second part of this sum says to verify P complement. That means if you take 2 times the complement of P, you should get P itself. Okay, so let's do that. First, P complement. Can you tell me what is P complement? Unmute yourself.
2, 8, 9.
And just circle it so that you may easily identify. 10. Okay. Now tell me 9,
9, 11, and 12.
And 12. So this is P complement. Okay, I will now erase this. Now what we have to do is we have to again take the complement of this set now. P complements complement. Okay, I'll take a different color. Okay, so now let's take the complement of this set. 2 is there. Here 8, 9, 11, and 12. Now can you tell me the complement of this set?
Yes, sir. 1.
So 1,
3,
3,
7,
7,
and 10.
and 10. Now what can you tell me of this and this?
The same set.
It is the same. It is the same. Therefore, we can say P complements complement is equal to P. Hence, verified. Is this clear?
Yes, sir.
Okay. So we'll move on to the next one. Okay, fourth sum of practice set 1.3. A is 1, 3, 2, 7. Then write any three subset of A. Any three. Can you tell me anything? But it has to be a subset of A. Unmute yourself. Unmute it.
3 and 7. Then
Give it a name. Give the set a name. So B, let's say B.
No, B.
Okay. So therefore B is a subset of A. One more.
C equals 1 and 2.
Any more number you want to put in this?
No, sir.
Okay. So C is a subset of A. One more. You can take with 3 elements also.
I know, sir. I know.
Yeah.
D equals curly brackets 1, 3, 7.
1, 3, 7. Okay, good. So D is a subset of A. Fine, very good. Fifth one now, fifth question. Write the subset relation between the sets. Okay, so P is the set of the residents of Pune. H, the residents of Maharashtra. M is a set that denotes residents of Madhya Pradesh. I denotes for Indore. B denotes the residents of India. Okay, B. And now you have to tell me which set is a subset of which other set.
Set P is a subset of H.
Is a subset of H.
H.
Okay.
Then
Correct.
set M is a subset of I. No, the set I is a subset of M.
I is in M. Okay. Indore, I is a subset of M. Madhya Pradesh. Okay.
P is a subset of B.
P is a subset of B. Is this what you said?
Yes, sir.
Okay.
I is a subset of B and all the sets.
Okay, so I is a subset. So you mean this, right? H is a subset of B. M is a subset of B. And what is left?
None, sir.
Done. Okay. Anything remaining?
I don't think so, sir.
Okay. So P is a set of residents in Pune. So P is a set of B. That is India. So this was correct what you said. So residents of Pune are residents of Maharashtra also. So P is a subset of H. Okay, H denoted residents of Maharashtra. M is a set of all residents in Madhya Pradesh. So the residents of Madhya Pradesh are residents of India. So M subset of B. This also what you said is correct. I is set of all residents in Indore. So the residents of Indore are residents of India. So I is a subset of B. This is also what you said is correct. B is a set of all residents in India. So the last thing that you said, P subset of H, H subset of B, and P subset of B. And all of them are residents of India. Okay. Second one, you have to denote which set can be the universal set for the following sets. So residents of Pune, Madhya Pradesh, Indore, and Maharashtra. Okay, in this same set, in the same one, which will be the universal set?
Set B.
Set P, correct. So this will be the universal set. Why? Because rest of all of these are subsets of this. So this will be my universal set. Correct. Okay, this is the way we write it, okay? The residents of Pune, Madhya Pradesh, Indore, and Maharashtra are all residents of India. Therefore, P can be the universal set for the above sets. Okay, this is the way you will write it. So let's move on now to the next question. Question number 6. Which set of numbers could be the universal set for the given sets below? Okay, so some sets will be given to you and you have to tell me what will be the universal set. The first one, A, is a set of multiples of 5. Okay, can you tell me what will be in this in listing method? Multiples of 5. Unmute yourself.
5, 10, 15, and dot dot dot.
Correct. So this is multiples of 5. B is set of multiples of 7. How will this look like?
7, 14, 21, dot dot dot.
C is the set of multiples of 2. How will this look like? Multiples of 12.
12, 24, 36, dot dot dot.
Okay. So can you decide a universal set for this? One thing you should note, that set A, B, and C should be a subset of that set. Then only it will be the universal set.
Sure, is 5 the universal set?
Is what? 5?
5 the universal set? Is 5 the universal set?
Empty set. No. Empty set. You're talking about this, right? Are you talking about this? 5 or 5? What did you say?
5 is the universal set.
No. You're talking about this, right? This 5 or this? This.
The number 1.
No. I'll repeat the definition of universal set for you. Universal set is a main set and all other sets should be the subset of your universal set. Now, in this case, what is given? In this case, all other sets are given and they are asking you to tell which could be the probable universal set, main set. So A, B, and C should be the subset of your main set. Okay, A, B, and C should be inside your main set. So decide some main set for this.
Empty.
Empty, but A is not there in empty set. No, A is not a subset of your empty set. A is not a subset of an empty set. It has to be inside it. Can you think about set of natural numbers? What is set of natural numbers? N. What is this?
1, 2, 3.
And so on. Is A inside this?
Yeah, yes, sir.
Is B inside this?
Yes, sir.
Is C inside this?
Yes, sir.
So can this be the universal set?
Yes, sir.
Yes. Can you think of something else now?
Whole numbers.
Yes, correct. Whole numbers can also be the universal set. 0, 1, 2, 3, and so on. Are there any more possible?
Integers.
Yes, correct. We saw it, natural number, whole numbers. Integers also can be the universal set for it because A, B, and C all are inside this, all are inside this, and all are inside this also. Then we have said rational numbers also. You have to anyways give only one answer. I am just giving you a list of all possible answers. Okay, so one of the possible answer is set of Q. Q is rational numbers. I will repeat a definition of rational numbers. Rational numbers are those numbers which you can write it in the form of fraction. That is P upon Q form. Any number which can be written in the form of P upon Q is a rational number, and the denominator, that is Q, should be not equal to 0. Then only it will be a rational number. If the denominator is 0, then it will not be a rational number. Okay, and this P and Q should be an integer, positive or negative, anything. So that is a rational number. I'll repeat, a rational number is that number which you can write it in the form of P upon Q, that is fraction, and Q is a non-zero. So this all are inside the set of rational numbers. So this also can be a universal set. Is this clear?
Yes, sir.
Okay. So since A, B, C are subsets of N, set of natural numbers, W, set of whole numbers, I, set of integers, and Q, set of rational. So either one of this, any one, you can take it to be your universal set for A, B, and C. Is this clear? Okay, so P set of, same thing we have to do. P and T is given. You have to decide your universal set. Firstly, how will set P look like? What will be in P? P set of integers which are multiple of 4.
Dot, dot, first dot. Curly brackets, sir. Dot, dot, dot. -1. No, -4, -4. 0, comma 0. 4, 8. Dot, dot, dot.
So since you have written 8 here, put -8 also here. So this will be P. And what about T? Set of all even square numbers.
4,
Square of 3.
but it's an odd number.
Yes, so you cannot take 3. Square of 4.
16.
16. Square of 5.
36. But 5 is an odd number.
Cannot take
36.
it. Okay. So it's 36. And dot, 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 dot. Now tell me which will be a suitable universal set for this.
Integer?
Yeah, set of integers. Correct. I. So P is a subset of I and T is also a subset of I. So set of integers will be a universal set. So P is a subset of one small mistake I have done. So after this, you will write set of integers that is I minus 2 minus 1 0 1 2 will be the universal set. Be the universal set as P is a subset of I and T is also a subset of I. Is this some clear? Whatever I wrote? Yes?
Yes, sure.
Okay. Okay. Question number 7. Let all the students of a class form a universal set. Okay, so all the students in a class is the universal set. Okay, any class. Let A be the student who secure 50% or more marks in maths. Okay, so set A is all those students who have got 50% or more in maths. Then write the complement of set A. So what will be complement of A? Unmute yourself. Unmute. I can't hear.
The complement of A would be the students who have got marks below 50%.
Correct. Correct. So here, U is a set of all students of a class. A is students who secured 50% or more marks in maths. So A complement, as you said, will be student who secured less than 50% marks in maths. So this way you will write it down. Okay, so with this, we have finished with exercise 1.3. Okay, so I will upload the recording. So from there, you write it down. Okay. If you have any doubts from our previous concepts, you can ask me in the next class. So now in this, we will study new concepts. So till now, you know what is a set. You know what is a types of sets. That is a singleton set, equal set, finite set, infinite set, and null set. Then you saw what is a subset. Then you saw what is a universal set. And then complement of a set. Now we have more further concepts. So in the next concept is called as operations on sets. Now what do you mean by the word operation? What is the meaning of the word operation? In maths, operation means, suppose if I say operation on numbers. Now what operations can be done on numbers? You can any two numbers you can add, any two numbers you can subtract, any two numbers you can multiply, and any two numbers you can divide. So these are the operations that are used on numbers. Okay, these are the operations: addition, subtraction, multiplication, division. These are the numbers these are the operations that you can do on numbers. But on sets, we have a different kind of operation. So let us see one by one. What do you mean by addition of two sets? So when I say addition of two sets, when I say subtraction of two sets, when I say multiplication of two sets, okay, but we don't use the word addition, subtraction, multiplication, division. We use some other words for it, but the meaning is the same. So when I say addition, that means combining two sets. When you say subtraction, that means separating two sets. Okay, so mostly we'll see two types of operations on the set, and that will be addition or subtraction, but they will not be called as addition and subtraction. We have different name for it. So let's see the names for it. So first one is called intersection of two sets, and disjoint sets, and union of two sets. So disjoint is same as subtraction, union is same as addition, and intersection is same as multiplication. And number of elements in a set, we don't have anything called as division. So only three operations we have: disjoint, union, and intersection. So intersection is like multiplication, disjoint is like subtraction, and union is like addition. So we saw Venn diagram also. So a set is represented by a closed figure in a Venn diagram. And you know what is a subset? If B is a subset of A, that means all the elements of B are in A, or B is inside A. Then you saw universal set, a suitably chosen non-empty set of which all the sets under consideration are subsets of that set. Then that set is called as a universal set. Then you saw complement of a set. So if B is a subset of a universal set, then set of all elements in U which are not in B is called as a complement of B. Okay, now we'll see the very first operation on set, and that is intersection of two sets. The intersection is same as a multiplication, but you don't think about multiplication. Think about when I say intersection, what comes in your mind? What do you mean by intersection?
Crossing paths.
Yes, correct. Crossing paths. So suppose if this is a line 1, and this is the next line 2. So these two lines are intersecting, but where? Where are they intersecting? They're intersecting at this point, correct? Now this point is called as the common point. Why common point? Because that point lies on both the lines. Okay, so that intersection point is called as a common point. In the very similar way, intersection of two sets, you can call it as common elements, we'll call it common elements in both the sets. So suppose A and B are two sets. The set of all common elements, okay? Common elements of A and B is called intersection of set A and set B. So intersection of two sets is denoted by this letter A intersection B. This is set of all elements common in A and B. In set builder form, it is written like this: set of all x such that x belongs to A and x belongs to B. That means the elements which are both in A and B. It is denoted by this letter. This is called as intersection. So this is called as A intersection B. Is this clear? Have you got a rough idea of what intersection is?
Yes, sir.
Okay. So let's see a very simple example. A is the set 1, 3, 5, 7. B is the set 2, 3, 6, 8. Okay, before doing the Venn diagram, looking at it, can you tell me which numbers are common in both?
3.
Only 3 is common. So A intersection B will be 3. Now let's try to imagine this on a Venn diagram. So this is set, the first circle is set A, and A has the element 1, 3, 5, and 7. So I'm just writing. I'm not writing 3 for now because 3 is common. And B has elements 2, 6. A has element 1, 5, 7, 3. B has element 2, 6, 8, and 3. So if you see this shaded portion is called as the intersection portion or common part for A and B. So this denotes A intersection B. And in A intersection B, there is only 3. Is this clear? Have you understood the Venn diagram?
Yes, sir.
Okay. So the element 3 is common in set A and B. So A intersection B is equal to 3. Okay, look at this example. A is 1, 3, 9, 11, 30. B is 1, 9, 11. Can you tell me what will be A intersection B?
1, 9, and 11.
1, 9, and 11. So these are common. So in Venn diagram form, okay, I want you to draw the Venn diagram, and can you draw on your notebook and show it to me?
Done, sir.
Okay. You have done it like this, no? A, and then you have done B. And just in the intersection, you have written 1, 9, 11. It's correct. What you did is correct. But one thing, note that. One thing you have to note carefully. can you see that B is yes?
Yes, sir.
So now can you tell me how the Venn diagram will look like? B subset of A means B is inside A.
Do a circle first, and then the elements which are not in B will go into that circle. Then we'll draw another circle, and inside that will be the elements of B.
So can you do it?
Yes, sir. Done, sir.
Can you show it to me? Yes, 1, 9. Correct. Correct. Very good. So it will be like this. And you have drawn like this. Okay, correct. So B is inside A. Okay, now one thing from this particular example, one thing to note that A intersection B is 1, 9, 11, correct? Yes. And B was also 1, 9, 11. So what can you see in these two sets? What type of sets they are?
They are equal sets.
They are equal sets, correct. So A intersection B is equal to B. Now, why is this happening? Why is this happening? Can you try to tell me why is this happening? Why are these two sets coming equal?
Sure, cause B has no other number in it except these numbers.
Yes.
And the same numbers are in A.
Yes, correct. If I put it in simple words, okay, is it because B is a subset of A? That is the reason this is happening. B is inside A. That is why the
Yes,
intersection. That is why A intersection B same as B. So from here you can conclude that here in this particular example, set B is a subset of A. So this we can generalize it, and we can say this will happen for any sets, for any two sets that you take. If B is inside A, then A intersection B and B are equal to each other. Have you understood this property? This is a property. Is this property clear? Do you have any doubts in this? Unmute yourself.
I understood.
Understood. Okay. So if B is a subset of A, or in simple word, if B is inside A, then A intersection B, that is a common point, common elements, and B, both of them will be equal to each other. And that is the same thing happening in this example. Okay. The next type of set is disjoint set. What does the word disjoint mean? Can you say? What is the meaning of disjoint? Unmute.
Which were made apart, sir. But what?
Yes. So joint means something that is combining two sets. Disjoint will be something that is not combining to each other. So intersection, what does intersection tells you? Intersection tells you that the common elements in both the sets. While disjoint means there is nothing in common between those two sets. So if you look at this example, A is 1, 3, 5, 9, B is 2, 4, 8. Is there anything common in them? No, there is nothing common. So they are disjoint. They are not joining to each other. While in intersection, they are joining to each other. So this set is same as the name that it says, disjoint. That means they are not joining. They are not nothing in common. So confirm that not a single element is common in set A and B. So they are completely different from each other. So A and B are disjoint sets. Is this clear? Disjoint sets? Yes. Nothing in common.
Yes, sir. I understand, sir.
So disjoint sets will look, if you go to draw the Venn diagram, then they will look like this. Two separate, completely different sets. Disjoint. And when you show intersection, they should be touching each other when you show intersection. So these two sets, these sets are completely different from each other. So set A and B are disjoint. They are not touching. So disjoint. Nothing in common. So if you go to draw the Venn diagram for disjoint sets, you will have to draw two separate circles. Now last is union of two sets. Okay, just by the name, can you tell me what would be union?
Together, sir.
Yes, correct. Together. Yeah, correct.
Combine and together.
Combine, all together. That is union of two sets. So let's see, A and B are two sets given to you. Then set of all elements of set A and set B is called as the union of two sets. Okay, set of all elements from A and B. Together you take it, and that is called union. Union is written as this letter A, U, B, and this is read as A union B. Is this clear? What is the meaning of union, how to write it, and the symbol? Yes?
Yes, sir.
Okay.
Yes.
So in set builder form, union is written like this. A union B is set of all X such that X belongs to A or X belongs to B. That means all the elements from A and B you take and put it together. Even if they repeat, you write it just once. Let's see an example. You'll have a better understanding. A is -1, -3, 5, 0, and B is 0, 3, 5. Okay, before the union, can you tell me what is A intersection B? Common.
0 and 5, sir.
Correct, 0 and 5.
5.
Now we have to write union. Union means we have to write all together. So start with A, so -1, -3, 5, and 0. Anything remaining?
3.
3, no?
From
3.
B.
3. So this will be the union. You are writing all the elements together. Now, if you go to draw the Venn diagram, can you tell me now which elements should I write where? Let's start with the intersection. So what elements should I write here? This portion is intersection portion, okay?
0 and 5.
This is A intersection B. So here you will write 0 and 5.
And 5.
This I'll call it as A and this I'll call it as B. What elements here?
-1 and -3.
What about here?
3.
3. Correct. So this is my Venn diagram for this example. Is this clear, Venn diagram? This is incorrect. Can you spot a mistake in this?
Five shouldn't be there, sir.
Yes, 5 shouldn't be here, but 5 should be here. Okay, let's see another example. A is 1, 2, 3, 4, 5. B is 2, 3. Okay, I want you to write this and find out A intersection B, find out A union B, and also I want you to draw the Venn diagram for it. Now, before you draw the Venn diagram, one point to note that what can you see in A and B? Some relation.
We have two same numbers in it, sir.
So can we say that B is a subset of
Yes.
A?
Yes, sir.
So now, keeping this in mind, draw the Venn diagram. Okay, start with A intersection B first. Okay, before you show me the answer, look, see, can you see that A intersection B and B are same? Yes or no? Unmute yourself and tell me. Is it same?
Yes, sure.
Okay. Next, can you see A union B and A? Are these two same? Look at your
Yes,
answer.
sure.
They are same. Okay. Now show me. Yes. Correct. Correct. Very good. So from this example, you have to note one thing, that because B is a subset of A, the intersection is same as the smaller set, that is B, and the union is same as the bigger set, that is A. Okay, A is bigger set, B is a smaller set. Okay, so intersection is same as the smaller set and union is same as the bigger set. This thing is happening because B is a subset of A. Okay, because B is a subset of A, that is why this is happening. If this would not be happening, then this also will not happen. If B is not a subset of A, then this also will not be equal to. Is this clear what I'm trying to say? Yes?
Yes, sir.
Okay, good. So this was a Venn diagram, which you did it correctly. This is A union B, 1, 2, 3, 4, 5. And B is a subset of A. So A union B is same as A, and A intersection B same as B. And you got it all correct. Okay. The last concept is number of elements in a set. Okay. So if you see this, A is 3, 6, 9, 12, and 15. If you count how many elements are there in this set. So 1, 2, 3, 4, and 5. So there are 5 different elements in this set. So number of elements in set A is 5. The number of elements in set A, it is denoted as n of A. Okay, so number of elements in set A is denoted as n of A, and in this case, n of A is 5. There are 5 elements in set A. So n of A is equal to 5. Okay. Can you tell me now what will be n of B? Number of elements in set B? How much?
6.
6. So n of B will be equal to 6. Okay, now let's see number of elements in union and intersection of sets. Okay, this is a little lengthy concept, so this will keep for our next class. So till today, we'll just do up to here. So we have learned 3 new concepts. Intersection of 2 sets, that is common elements in both the sets. Then was disjoint sets. So disjoint sets, that are those sets in which none of the elements are common in each other. And then we saw union of 2 sets. The union of 2 sets means all the elements together. Okay. And last, number of elements in a set. So you count how many numbers are in the set, and usually number of elements are denoted by n of A or n of B, depending on whatever the name of the set. Yeah.
What if the numbers in a set are infinite?
Then we suppose if it is natural number. So you denote it by the sign infinity. Do you know this sign? Are you aware of this sign?
Yes, sir.
So this is infinite. But one thing to note that we usually don't work with infinite sets. We don't go to count in it. So in this particular concept, finding number of elements in a set, we will see only with finite. We'll only work with finite sets, not infinite sets. But yes, this concept is there. You denote it with the letter infinity. Okay, so in our next class, we'll do number of elements in union and intersection. Okay, now next class, I want to take tomorrow. Is that possible? Tomorrow, same time, 5.
Yes, sir.
5, no, 5:30. Is 5:30 better? 5:30?
Okay, sir.
5:30? Okay.
Yes, sir.
So I'll see you then tomorrow, 5:30. Okay, so we'll stop here.